Assalamualaikum everyone, and have a good day to the all panelists, Engineer Zainal Abidin and Mr. Muhammad Anif. My name is Nurul Yusnainy binti Muhammad Yusof. My metric number is 2018224718. Today I am presenting my final year project proposal under the title of Look Heat Pipe with Nanofluids. I am under supervision by Dr. Muhammad Fairuz. So let's start with the introduction of loop heat pipe and the nanofluids. So loop heat pipe, it is used to transmit a huge amount of heat within a long distance in a loop heat pipe. It also known as super thermoconductors or heat transfer device. So the loop heat pipe has many advantages and it possesses all the main benefit of the conventional heat pipe. So the advantage of loop heat pipe is it has a high heat transfer performance, long distance heat transfer, and small heat transfer temperature difference. So for the nanofluid, it is a fluid that containing nanometer size particle. It made of metal, oxide, carbide, or carbon nanotubes. So the nanofluid are expected to give better thermal performance than conventional fluid due to the presence of suspended nanoparticles which have high thermal conductivity. The figure illustrates the component part of loop heat pipe, but the main component part of loop heat pipe consists of 5, which is evaporator, condenser, compression chamber, and transportation line, which is vapor line and liquid line. There are few researchers that use a common shape of the evaporator, which is cylinder, but a flat type of evaporator can minimize the thermal resistance than using the cylinder shape of evaporator. So let's move to the first literature review, which is overview of the loop heat pipe. So the loop heat pipe is a passive two-phase of heat transfer device where it transfers the amount of heat within a long distance that rely on condensation and evaporation of the working fluid that we use. So the evaporator, compression chamber, condenser, vapor and liquid line are the common component parts of the loop heat pipe. Based on the previous study, the liquid will be vaporized under the condition of steady state. The type of the working fluid, the fluid charge ratio, thermal properties, and the designation of the loop heat pipe can affect the thermal resistance and the capability of maximum heat transfer in the loop heat pipe. So let's move to the second literature review, which is the variety of loop heat pipe. So there are two varieties of loop heat pipe, which is the miniature loop heat pipe and novel fin loop heat pipe. So there are more studies that focus on loop heat pipe to the miniature loop heat pipe. So the miniature loop heat pipe is designed for appropriate application purpose in various industries. It is a heat dissipation device that used in electronic application. So the miniature loop heat pipe was developed by the researchers Titarai that used graphene water nanofluid as the working fluid to investigate the heat transfer performance. So to prevent the reverse flow, the transport line was designed in different diameters and also to increase the flow rate of condensed liquid. So other researchers also state that the thermal resistance in miniature loop heat pipe is depends on the usage of mass concentration of nanofluid and the power supply. So from the experiment result, it states when the power input is higher, the lower total thermal resistance and temperature difference happen in the miniature loop heat pipe. So for the novel fin loop heat pipe, other researchers that state that the air velocity and heat power input can affect the total thermal resistance in a loop heat pipe. So the result of the experiment state that increasing of air velocity and heat input can influence the total thermal resistance to increase. So let's move to the last literature review, which is the experimental validation and simulation on loop heat pipe with nanofluids. So there are several researchers that focus more on using nanofluid instead of using pure water or distilled water as a working fluid in a loop heat pipe. So based on the research summarized by Sonawan, Shinde and Bisons, there are few researchers that give more attention on experiments of thermal conductivity than heat transfer characteristic due to the importance of thermal conductivity to enhance the heat transfer performance of a working fluid. So the nanofluids have a faster steady state compared to pure water or the ions water in a loop heat pipe. So in previous study, the numerical modeling for three-dimensional of fluid heat pipe was developed by Jovin Joss and Rajesh Baby. The simulation was to analyze the effect of silica water nanofluid on thermal performance in alu heat pipes. So the result from simulation proved that the nanofluid can reduce the evaporator temperature than using the ions water in alu heat pipes. So it is because the nanofluid can enhance the thermal properties of silica nanoparticles. So the experiment indicate that the nanofluid have a faster steady state in loop heat pipe than the ions water. Next, the researchers Kanasaran, Abdullah and Yusof was developed the experiment to identify the heat transfer characteristic impact on alumina nanoparticle in alu heat pipes. So from the result, alumina water nanofluid has a great thermal performance than pure water. The thermal resistance of nanofluid also decreases when the mass concentration of nanofluid is increased. So, the lowest thermal resistance in alu heat pipe also depends on the suitable mass concentration of nanofluids. Refer on the previous experiment, the researchers have investigated the impact on heat transfer characteristic when using the range of mass concentration of diamond nanofluid from 0% to 3% in alu heat pipe. The lowest thermal resistance in alu heat pipe is shown when using 3% mass concentration of diamond water nanofluids. The thermal resistance happens because of the vapor bubbles formation at the liquid-solid interface. So when using the higher mass concentration of diamond water nanofluids, the total thermal resistance in alu heat pipe will be decreased. So next, the nanofluid has produced the smaller size of the bubble flow pattern, which indicate the higher heat transfer characteristic in alu heat pipes. So the experiment to analyze the heat transfer performance and thermal conductivity effects was developed by the researchers, which is Tans, Muhammad Abdullah and Frank Gunasegrans. So the diamond water nanofluid can attain the higher heat transfer coefficient due to the low particle mass concentration used than pure water. So the result have shown that the bubble flow pattern in the vapor line have the smaller size of diamond water nanofluid, and it causes the higher heat transfer characteristic in alu heat pipe compared using the pure water. So let's move to the important part, which is problem statement, objective, and scope and limitation of the project. So for the problem statement, as we know, nowadays the loop heat pipe with conventional base fluid could not provide a great thermal performance due to the higher thermal resistance that produced in the industry. To overcome the problem, the type and mass concentration of nanofluids are used to ensure a better thermal performance and higher efficiency of nanofluid in a loop heat pipe. So in the previous study, the experimental result indicate that the lowest total thermal resistance and better thermal enhancement rate when using nanofluid than using pure water. A lot of studies have been using nanofluid as a working fluid in a loop heat pipe instead of using pure water. It is because the nanofluid provide the higher thermal conductivity and lowest thermal resistance in a loop heat pipe. So for the objective of this present study are to perform heat transfer assessment of the nanofluids in a loop heat pipe using CFD software and to compare the performance of nanofluids and pure water in a loop heat pipe. So for the scope and limitation of the project, this present study will focus on 3D of loop heat pipe simulation by using CFD software. So the nanofluid and pure water will be used as the working fluids. The model of loop heat pipe will be designed by using CATIA. The component of the loop heat pipe should consist of the evaporator, condenser, vapor line and liquid line. The thermal performance of nanofluid will be analyzed and compared with the pure water. So this is the methodology. The figure show is the flowchart of the design and simulation of the loop heat pipe model. So in the present study, the CATIA will be used to develop the CAD model of loop heat pipe. Then the loop heat pipe will be simulated using CFD software. The loop heat pipe model will be imported from CATIA into CFD commercial software to analyze the thermal performance of nanofluids in a loop heat pipes. So the simulation of the loop heat pipe will be performed in CFD software. So for the CFD steps, firstly we will do a performation of the model. Second, we will do the set the boundary condition, which is the boundary condition consists of the velocity and temperature at the outlet, pressure at the outlet, heat transfer coefficient at the surface of fins, and heat flux in the bottom plates. So for the third, we'll set the solution of solver, which is we use the volume of fluid method. So for the fourth, set the initial condition and calculation setting. And for the fifth, we will do post-processing for the model. So let's move to the interesting part, which is the mathematical modeling of the loop heat pipe. So the table show is the specification of the loop heat pipe, and the figure show is the model of loop heat pipe using Katia. So for the specification of loop heat pipe, so we have a 4 component part, which is evaporator, condenser, vapor line, and liquid line. So for the evaporator, the dimension is for the length is 50 mm, for the width 50 mm, and for the height is 4 mm. And the material used is copper. So for the condenser, the length is 150 mm, the width is 100 mm, and the height is 1 mm. So the material used is aluminium. So for the vapor line and liquid line, the outer diameter is 15 mm, inner diameter is 13.5 mm, and the length is 250 mm, and the material used is copper. So from the specification of the loop heat pipe, we use the dimension to develop the loop heat pipe using Katia. So this is the expected result. At the end of this study, the higher thermal conductivity and lower thermal resistance when using nanofluid in a loop heat pipe are expected. So the simulation result will indicate that the nanofluid has a better thermal performance compared to pure water. The higher thermal conductivity when using nanofluid due to the ability of nanofluid to absorb more heat and enhance the heat removal in the loop heat pipe. By using nanofluid as the working fluid in this present study, the thermal resistance will be decreased than using pure water. The evaporator temperature will be increased when using nanofluid and attain steady state faster compared to pure water. So last but not least, the final year project will focus on modeling and simulation on the loop heat pipe in terms of heat transfer performance of nanofluid by using CFD commercial software. The parts of the loop heat pipe consist of the evaporator, condenser, transportation line, which are vapor line and liquid line. So the working fluids that will be used are nanofluids and pure water. Then the mathematical modeling of loop heat pipe will be developed in this study by using Katia and imported to the simulation software, which is CFD. So the loop heat pipe model will be simulated to observe the thermal performance of working fluids. So that's all from my final year project proposal. Thank you for watching. Stay safe and take care. Thank you.